Hi, I am Jens Malmgren. The first thing you will be wondering, why is this guy speaking with such a funny accent? Well, I speak like this because I am from Sweden. Actually, I am in Sweden, in my cottage right now. And this cottage, it got its own website, and I will leave you a link in the description. I'm sitting here with a ball. And this ball looks very much like a Wikipedia logotype. And perhaps you have been wondering, how would it be to create such a ball yourself? Then this video provides you great value because I will tell you exactly how I made this ball with a program called Fusion 360. Fusion 360 is very complicated, so it's nice to have someone who brings you the steps that they use to create something complicated like this. This ball, it got 12 pieces, and each piece has 5 sides. In the mathematics, this is called a Pentagonal Dodecahedron. So next I will do, we will fire up Fusion 360 and start exploring how to make this model in that program. The first thing I do is that I will give my empty document a name. I call it Pentagonal Dodecahedron. Then I expand this origin plane group and make it visible. From the XY plane, I will construct an offset plane, and I will make it 18 millimeters from the origin. Press enter. And then from this new plane, I create a sketch. And on this sketch, I will draw a circumscribed polygon here from the center. And I will give this polygon a radius of 11.119 millimeters and 5 sides. Then I go over here to the sketch palette, and then I select the horizontal vertical constraint, and I give one of the sides this constraint. Now I will construct a new plane from an angle, and I'll select one side. So I select this one, like so. And the angle will be 63.435 degrees. And then from this new plane, I create a sketch. And on this sketch, I will first project points from the previous. So I press P and I select 2 points. And now I can draw an edge polygon with help of these 2 points. And I give it 5 sides. If I were supposed to extrude the pieces right from these planes, the pieces would get too close to each other. So that's not a good idea. I need to have a distance between the pieces. So I will do that by pressing O for offset, and then select a polygon and then enter minus 0.15 millimeter and press enter. Then I will do the same thing on my previous sketch. Press O, minus 0.15 millimeter. Now it is possible to extrude this inner profile here. So I can select this profile here, and then I press E for extrusion. We move this to the center here. And I will extrude minus 8 millimeter. Let's see. Now you can see that it is extruding this profile towards the origin. But I want the sides of this shape here, this puzzle piece, to point towards the origin. To do that, I will use the taper angle. That's over here. So I enter minus 31.697 degrees. And so are the sides pointing towards the origin, the way I want. So I do the same on the other puzzle piece. So I press E for extrude, then I enter minus 8 millimeters, enter minus 31.697 degrees. So now we created the first pieces. My puzzle will need 6 of these. And one way to do that is to use the circular pattern tool. So we will see here, we have circular pattern here. And I select bodies, Z axis, like so. And now we, the number of pieces, I want 5. This looks correct, so I press OK. Now we have first 6 pieces, and these 6 pieces, that's all the pieces I need to make an entire ball. Some of these pieces we need more of them when we print, and some we only need 1. This is a good moment to talk a little bit about this distance between pieces. What is this distance? So to find out, we can press S and then we search measure, and then we select this edge and then this edge. Fusion 360 gives us that the distance is 0.255 millimeter. We're going to use this distance many times when we're constructing this puzzle, and a way to do that, to reuse values, is to make a parameter like this. So I will create a D parameter for delta, and then I will give it 0.255 millimeters and give it a little comment, delta or tolerance. A really good thing with this feature is that in the places where I've used this D parameter, later if I go in and change the values of D, then the entire construction would follow wherever D has been used in my drawing. So that is a really good feature of Fusion 360. Now it's time to start talking about the construction, the features that will connect 2 pieces with each other. I've been searching for the official terms for this, haven't really been able to find that. So, for example, if this puzzle piece would have something sticking out and gripping into this other puzzle piece, I will call that an ear. The hollowness on the other side, I will call that the ear socket. We need a drawing for the ear and the ear socket. And to do that, we would need a plane between these 2 pieces. So we will construct this plane. We will make a plane through 2 edges, this edge and this edge. So that is the plane between 1 and 6. So to be able to find it back, I will call it 1, 6. And then we will need a sketch for this plane, and that is the 1, 6 sketch. So now it's time to start drawing. The first thing I do is I press L to get the line tool. I can remove this view of the origin group. And then I will hover over this baseline here. At this point here, we see a blue triangle, and that means that I am right now at the midpoint of this baseline. So I will click there, and then I make a line out from this place. And I will give this line the length 3 millimeter. Then I select the line, press X to make it a construction line. I will need the same construction on the other side, so I press L and I draw that like so, and then I press 3 and then enter. Then I select the line, press X. Well, this line here, I want it to be perfectly perpendicular to the baseline. And to do that, I select a constraint over here, the perpendicular constraint. So select that one and that. And now we got a symbol for the perpendicular, and it became black, which indicates it is fully constrained. So I do the same thing on this side with the perpendicular tool, and then I select this, and here happened the same thing. But here we have the perpendicular icon and the line became black. And now we continue with drawing a circle from this spot, and I will give it the diameter 5 millimeters. And I do the same over here, 5 millimeters. Then I make a line between plates on the surface of the circle to the surface of the other circle, and I do the same. I do the same over here. This section here between the circles, I want to have that perfectly centered. To do that, I use the symmetry tool, and I select one object and then the second element, and then I select a symmetry line, and that will be my construction line. So now it is totally symmetrical. And then I want the distance between these two lines to be defined. So I press D and then select the two lines, and then I enter a value 3 millimeter. That's going to be fine. Then I need to remove a bit of this part of the circle between these two lines. So I press T and remove parts of the circle. And as a finishing touch, I select O for offset, select the parameter of this drawing, and then I give it the distance D for delta. So this is the basic drawing for my ear and ear socket. This inner part, that's the ear, and here the outer part of this drawing, that is the ear socket. Now it's time to use this drawing. I will extrude with help of this drawing very many times, and in that case it's really handy to specify a parameter for the value that I will extrude. So we go into the change parameters and we add ear extrude parameter, and we give it 5.85 millimeters, and this is the ear extrude parameter. So with my parameter specified, I can select profiles that I want like to extrude, like so. Then I press E, and then I can enter minus EE over here, and then I want to have minus D as well. Then I can decide that I want to extrude only body 1 and not body 2, body 6, like so. So this is our first ear socket in this puzzle, and in here I will later make other pieces sticking out that will fit in here, that will hold the puzzle together. So now I could go about and do the same drawing on all 5 sides, but there is a more clever way to do that. I can use the repetition tool again. So we can go to pattern, circular pattern, and then I select the pattern type feature, and then over here I select the feature I want to repeat, and then I select axis. It is the Z axis, and how many? I want 5, and then I press OK. So this was a really quick way of doing it. So now we can go to piece number 6, and we can go and do the same over here. I select this pattern over here, I select the profile, and I select here like so, and then I extrude. That's the same thing. Minus EE minus D, and I only cut body 6, so that's fine. Now I would like to use the same trick with the circular pattern tool, but the circular pattern tool, I can only use that if I have an axis. So I would need an axis over here. So do we have that? No, we don't. So here in the construction menu, I can see various ways of constructing axis. It would be nice, for example, to use axis perpendicular to it at a point. So then I could specify that over here. But I don't have that point. And if I just point with my mouse, it's not going to be mathematically perfect. It's going to be off. We have something here, axis through a cylinder. So if we had a cylinder here in the middle, then we could use that tool. But we don't have a cylinder. Here comes one of the powerful features in Fusion 360, and that is this history timeline. You can see here below. We can go back in time to, for example, this point. And then we can say, okay, if we at this point created a cylinder on top of the pieces, then back in the future we could use that to create axes. So let's try this method. We select here this plane and we create a sketch. It is a sketch 2 cylinder. We project 2 points into this sketch, and then we create a polygon with 5 sides, and now we have the midpoint of this polygon. And here we create a circle by pressing C, and then we make it 5 millimeter, for example. And now we have 2 profiles over here. So we could go in here now. We select this profile, press E for extrude, and we extrude 0.5 millimeters, for example. So now when we go back to the future, we got the same cylinder replicated over all the pieces around the first piece. So now when we are back in the future, we can go in here and we can say, create me an axis through this cylinder, and there we got our axis. So I press OK, and this is the 6 axis. So now when we use the pattern tool, the circular pattern tool, we can select the feature. Then we can select the axis. It is this axis. We select 5 sides, and then we deselect one side so that we get the ear sockets on 4 sides, and one side there is nothing yet. So this looks great. Now we want to have a feature to stick out from this piece. So it would be nice to have access to this drawing over here. How are we going to do that? First we need a plane between piece 6 and piece 2. So it's the 2-6 plane, so to speak. So let's construct a plane at an angle, and this is the angle we were looking for. It is the 2-6 plane between here, body 6, body 2, and on this plane we create a sketch, and this sketch is the 2-6 sketch. So now we could start drawing here, but there's an easier way to do this. We can go over to the previous sketch and copy parts of it and paste it out in the new sketch. So we will try to do that. Edit sketch 1-6, zoom in a bit. Now I will pick out some elements from this sketch that I want to copy. So I hold the shift button and click on these elements. So I want to copy these pieces, so Ctrl C, then stop sketch. Then we go to 2-6 and edit sketch, and now we will paste. So Ctrl V. So here is the pasted sketch. So I can put it more into the location where I want it. Something like this. So far so good. It looks really promising. However, if I were supposed to, for example, move little points here of this sketch to get it to the absolutely correct spots, then we can try that now for a moment. So I start dragging here. As you can see, my drawing disintegrates, and this is because I'm missing important constraints here. So I press Ctrl Z to undo this. And let's talk about the constraints instead. So, for example, I want this line to be collinear with this line. So I select that constraint. So now they are collinear. We see those collinearity symbols. Then I want this point to be coincident with the baseline, and also this point to be coincident with this baseline. Now I want this construction line to be perpendicular to this baseline. And finally, I want this point to be at the midpoint of this baseline. And now my pasted drawing has been fully constrained and it's placed on the spot where I want it. At this point, I can now press O for offset and enter D for delta. And now I have the drawing that I need to create an ear over here. So, but before I do that, I will hide body 2 and select the profiles that I need. So that's the profiles. I press E for extrude and minus EE. Then I select join and OK. So this is our second puzzle piece. Alright, now I will need these drawings on all these places in this puzzle piece, and it will take some time to get them there. But I will use the same method all the time. I will copy, I will paste, put in constraints. And instead of having you look at this in normal speed, I have decided that you can look at it with 800 times the normal speed. I start now, and when I'm done, we continue with the construction of this puzzle. Now I finished putting out the drawings, and now I will start extruding the ears and the ear sockets for the different types of puzzle pieces. So I start this process by hiding most of these drawings like so, and then I will also hide puzzle piece 6. And then over here I want to select the different profiles for the ear socket that we want to extrude. Then I press E, minus EE, minus D. See? And then I create an axis through a cylinder or a cone, and then I can replicate this feature, create pattern, circular pattern, and I select the feature, select the axis, 5. For this case I need 3 ear sockets, and here we have 1, 2, so I can need this drawing, and I will create this ear over here. So extrude minus EE, and I don't want a cut, but I want a join, like so. Press OK, and then like we just did, circular pattern, want this feature replicated with this axis, 5 of these, and then I can remove those that I don't want. So this is our third piece. So we have number 6 here and number, as you can see. So the first piece has 5 ear sockets, second piece got 4 ear sockets, and now we are down to 3 ear sockets and 2. So our third piece, it will have 2 ear sockets. So now we can make that 2, 1, 6. They are finished, and the body body 1, 2, no, 1, 3. So here we now can select the profile we want, the ear socket. So extrude minus EE minus D. Like so. Construct an axis. Now circular pattern. We select the feature, axis. So like so, and then we can enable, for example, drawing. We do it with the 4, 3, 3, 4 over here. And we select profiles that we want to extrude. These two. We don't need body 4. Extrude minus EE. Excuse me. We extrude EE and we join. Then press OK. Then we create circular pattern. This is the feature. This is the axis. We want 5 of these. Deselect the ones with ear sockets. And then we press OK. So now we finished this piece. Select the profiles. Extrude EE plus D. When the arrow points down, it's a positive extrusion. If it points up, it is a negative extrusion. So that explains that. So now we have our ear socket. Create an axis through a cylinder or a cone. We need just one ear socket in this one, and then we need 4 ears, and this is piece 1 and piece 4, so we have a drawing 1 and 4. So we're done with 3, 4, and over here select this, the profiles we need. We extrude minus EE, and we make it a join. For the sake of it, we hide body 1, like so, and press OK. Then we can select the circular pattern, select the feature and the axis. I don't need this one. Alright, okay. So now we've finished this piece. In the last piece, we need all 5 ears. So we can have, for example, drawing between 1 and 5. So then this is the profile we need. So I can extrude that. This is minus EE. To join. Then I create axis through a cylinder and a cone and select this one. And now we can use the circular pattern tool. We can select the feature, it's this feature obviously, and then right. Okay. 5 ears. press OK this time. So now we got 5 ears, and this is the final piece. Now it's time to cut out the spherical shape from these pieces. The way we are going to do this is that we are going to use the combine tool. Combine makes it possible to cut one piece from another piece. And the tool we need, that is a box with a spherical hole in it, cavity. That's the tool that we need to cut these surfaces so that they get a spherical shape. But how do we create this tool? Well, first we need to create a box, and in the box we need to cut out a sphere. So I hide all these puzzle pieces, and I can hide the axis as well because I don't need these. And then we start with the origin. We want the box around origin. So I will create a box around the XY on the XY plane. So I create a sketch for that. And then I select the center rectangle. And I want it to be 100 by 100 millimeters. Then I want to extrude this. Well, I need to select the profile, and I want it to be 100 millimeter. So now we have a box completely enclosing the origin in the center. So I call this new body box 100. No, box 100. But that's just one part. I also want a sphere. For that I will use the sphere tool. So I go in here and I make this sphere 35 millimeter. Sphere 35. So now I have a box and a sphere. Now I want to subtract the sphere from the box to create the cavity for our cutting tool. So for this I use the S search tool, combine, right? Target body, that's the box. The tool body, that's the sphere. And the operation is cut. Then I press OK. So now I have a box with a cavity. It's kind of hard to see. One way of seeing it is by using the section analysis. So here I create a section analysis from the XY plane. Like so. And here you can see the spherical cavity in the box. Now, when we, for example, display puzzle piece number 2, and we zoom in on this, you can see how we look from inside, how this looks like. So what I will do now is to subtract the box from the puzzle piece to create the spherical surface of this puzzle piece. So let's do that. I press S, and here I have it already preloaded in the menu. The combine tool, I select target body, that's my puzzle piece. The tool body, that's the box. The operation is cut. This time I will keep the tool. So now when we hide the box, we have the puzzle piece with spherical surface. Now we just need to do the same for all these puzzle pieces. So S, combine. Target body is the puzzle piece 1. The tool body is the box, and I press OK. So this works nicely. Now I can remove, I can hide in the section analysis. Okay, S, combine. Target body is puzzle piece 3. Tool body is the box. Okay. S. Target body is puzzle piece 4. And this is the tool body. Yeah. S. Combine. Target body 5. Tool box 100. Okay. S. Combine. Target body 6. Like so. And I press OK. So now all these puzzle pieces got a surface that is absolutely spherical. What I need to do now is to save these as STL file. So I save it as body 1. Now I got my 6 different types of puzzle pieces saved as STL files. Now I can switch to program. Now I will use Cura to prepare my STL files for printing on my 3D printer. So I start by open the files that I just created. And as you can see, they are now opened with the orientation as they were created. So I will go in here and select lay flat. Yeah. I need to persuade it a little bit what side I want to have downwards, and then I use the lay flat functionality. I think I got them all. This one got 4 ears and 1 ear sockets. So these 4 pieces, they are all pieces I need only 1 of. These 2, I will need 4 of each. To do that, I select this one, multiply selected model. I select 3. Let's get 3 more of those. And I do Ctrl M and do 3 of those. Now I have all the pieces I need to make a complete ball. So now I can prepare this. It's properly sliced. And now I can save this file to my SD card. Eject the card and go to my printer and select BW body 6 to print. Now I started the print job of this puzzle ball. This printer is a BlackWidow from the Tevo company in China. It's a kit printer, you put it together yourself, which was quite fun actually. When I decided for this printer, There were a couple of things that I really appreciate. It has a huge build area. For a ready-made printer that you don't put together yourself, made in Europe or US, I've seen prices like 2 or 3,000 euros or dollars. Now you can buy this for 400 euro or something. I'm printing with ABS here. It's a very challenging material, and to do that I also built an enclosure around the printer. It's a box with transparent doors in the front. The temperature inside the box will be around 45 degrees Celsius. It has a heated bed, so this is 110 degrees. The hot end, it's 250 degrees. To avoid having the filament melt too early, I put this vacuum cleaner hose transporting room temperature air directly to the fan of the hot end. So this will take a couple of hours. When it's finished, we have a look at the result. Now the print job is finished. I took the glass plate with the print and moved it to my desk. Here I am showing you stills from the result. I've zoomed in as much as I can so that you can see the quality of the print. As you can see, there is a lot of stringing going on in this print. In this case it doesn't matter so much because I will need to cut away all the support material anyway. In another case it wouldn't be nice to have stringing, and then I had to adjust that. It has been fantastic to have you watch this entire movie. You've been really patient, and if you like it, please give me a thumbs up, and you can even subscribe to my channel if you like this content. Have a nice day.